All right, welcome. In this video, I'm just going to walk through some examples of some problems you might encounter on the homework. So this would be homework number 2. And I've set the working directory here. So just run that. And then work through an example of a problem. Let's suppose I enter this here. And I didn't enter the full name. I click run. It gives me an error message down here that you can see. Cannot open the file, no such file, right? Cannot open the file because there's no such file. So if I get an error message, it just tells me there's something I need to look at again. And in fact, right, the actual name of the file that I want to look at is su22 project.train. I just need to have that typed in correctly, and I just need to check some things. I could also do something like header equals true, make sure that it's reading the first row there as the header, something like this, but I can click this and it pulls this up. Now I actually want to work with a subset of these data, so I'm going to do this. TR is TR, and then I'm going to do a subset. So I'm going to put these brackets there, and I'm going to just get the first, let's say, 100 rows. So say 1 through 100, and I just want the first 3 columns. So 1 through 3, and I'm going to do that. So now I've just made a smaller data set that I'm going to work with for this example. And I can just do summary for this data set, and it gives me some summary statistics, right? The minimum, it gives me the 5-number summary, but it also gives me the mean for these. So let's suppose I also want just more directly the mean and the standard deviation, though the mean is in these, right? So it shows me the mean for these variables. But let's suppose I want the mean of y. So mean, I'm going to have TR as the data set and y, and I can get that out. And it shows me what the mean is, 285.505, which is the same as this value before, just rounded a little differently. It goes out to an extra decimal place. I can get the standard deviation, so SD, and then TR and Y, and that'll give me the standard deviation. And I get it out, 61.12. So I've got that. All right, let's suppose I want to find a box plot. It could be a histogram, could be a scatter plot, could be whatever, but I'm just going to type in box plot. And I'm going to go with TR and Y, and I'll be able to take a look at it. And I see that over here on the right, I've got this box plot. And I can look at that and see whatever I want to take from that. If there were an outlier, it would have a dot either up towards the top or down towards the bottom or both, and those would be outliers, for example. Let's suppose I want to find a z-value. So again, I just recall what a z-value is. It's the value minus the mean, that difference then divided by the standard deviation. So I would have something like TR y minus the mean for that, TR y. And then I want to take this expression, so I need to put some parentheses around here. And I need to divide that by the standard deviation of this variable. Now you could wind up with a problem here. I'll just give an example of how you could get this wrong. You might have, instead of typing y in there, let's suppose you divided it by the standard deviation of x1. This is going to give me a wrong answer, right? So let me just type this in as, I'll say this is z wrong. But this is just an example of how you could get something wrong. And that comes in there. I would have values, but they're not going to be the correct ones. Right? So if I want to do this correctly, let me just copy and paste here. So z, and then what I actually needed to do is type the standard deviation of y and get that there. Okay, and I could have had something wrong in here too. Let me just go with something wrong again to get an error message. Suppose I forgot that slash. Let's just see what happens if I do that. And it gives me an error message. It just says down here, there's an unexpected symbol. So getting error messages just tells me to go back and look, see if I can find, probably missing parentheses or bracket, a division sign, an asterisk for multiplying. Maybe I'm missing this dollar sign. Maybe I've got something typed in wrong. It just tells me to go back and look to check things out. All right, once I've got that Z value, whatever it is I want to do with it, do that with it. So maybe I want to find the largest Z value or the smallest or whatever. But if I wanted the average for those Z's, the mean for the Z should be 0, right? It's centered things. It should have a mean of 0 and a standard deviation of 1. And so what is this? It's pretty close to 0, right? It's point, and then I've got 16 zeros before it hits 9. So it's, yeah, at some place way back there, R is rounding something in some way, but it's, for all intents and purposes, it's 0. And we could just do the standard deviation. It's going to be 1 or very close to 1. Yeah, it just shows it as 1 there. All right, so now we want to run a regression. So let's go ahead and build a model. So I'll just call it M for model. LM, and then let me just do this. Let's say we've got Y. I'm going to make a mistake here just for fun. And I'm going to do this on X1 and X2. And I'm going to say data equals, what did I call it? TR. And let's just see what happens with this. Again, it gives me an error message. Extra argument Y will be disregarded. Something didn't happen correctly. But I can type this out. Let me just see if it actually did anything. It did produce something, but it, I don't know if I'm going to trust it at the moment. So what I really want up here, though, if I see this warning message or I see some error message, it can make things a little iffy for me. So maybe I want to go ahead and redo this. So I try that, and then I maybe check summary for that and see what it gives me. Right. So it looks like before those values were from this regression, but again, warning messages, maybe they cause a little concern. Something's probably not quite right. Right, and then I can look at this and see what I need to see. Do I want the root mean square error? Do I want the R square? Do I want the F statistic? What maybe am I looking for? I'm looking for a coefficient. Right, so I would just want to read out what I might need from that if there's some question there. I can also plot out the residuals. So I'm going to do something though here. I want to make all of the 4 plots that are going to show up from the regression. So if I just do plot M, I know it's going to give me 4 plots, and this little line right here, PAR, and then MF row equals C22, that's going to make them all appear on one pane. This pane over here on the right-hand side at the bottom, and that's just going to make it a little easier for me. You don't have to do that. You can try things with just plot and see how that works for you, but this just makes it a little easier for me. So I do that, plot, and it produces some graphs or plots over here for me to look at. And I can find some different things there. So in this problem, you're going to have some things to look at like leverage values, and you're going to also want to look at normality. So you're going to want to build a QQ plot. So you're kind of reproducing these 2 things over here. I say reproducing, you're not necessarily going to make the residuals versus leverage plot, but it gives you an idea about what's going on over there. You can see maybe this far right value, expecting maybe the largest leverage is close to 0.14, right? It's above 0.12, close to 0.14. Maybe gives you some idea about things. Okay, so if you're at this point and you're trying to find the leverage, how might you do that? Well, you could find leverage values by, let's just say, lev, and I'll call it lev I for observation I, when I say that. And one thing I can do is I can type in influence, just hit that. And for the model, right, so that was M. And then I'll just put in here hat. It's going to give that to me. And I do that. And then I maybe want to find a particular value for that. Maybe want that average. Maybe I want to get the largest. So maybe I just say max, lev, and the ith leverage. And if I'm looking at this graph over here on the right, I'm expecting it to be close to 0.14 or at least bigger than 0.12. You can just check that out. And sure enough, it's 0.134. So between the 0.12 and 0.14. So just as an example there. Then I'm going to maybe want to test for normality. I see that in here, made a note for myself. So I want the standardized residuals. So I'm going to just call these the standards. You can call it whatever you want. And our standard for the model is what I've got. And it's going to give me these standardized residuals. And with that, I can just check what's the mean for standards. And I think it ought to be close to 0. And it is fairly close, right? 0.00026 or so, 0.0003. It's close to 0. So then I want to test, are those standardized residuals normally distributed? And one of the tests that I can do for this is I can do a Shapiro-Wilk test. So I'm just going to do Shapiro.test. It shows up for me. And I'm going to do that on the standardized residuals. So I'm just going to say standards here and click run. And it gives me for this a p-value. It gives me a test statistic. The easier thing to read here is going to be the p-value though. Again, follows the same rules as anything you would have done in a prerequisite course. If the p-value is less than or equal to alpha, you reject the null hypothesis. If the p-value is larger than alpha, you fail to reject. In this case, the null hypothesis is that the residuals are normally distributed. And if we were picking alpha of 0.05, we would fail to reject here. Another thing, though, that you can do if you're thinking about normality, you could construct a histogram. You can do this normal plot. So over here on the right, you can see this normal QQ, and that's what we've got going on here. So I'm just going to say QQ norm to build this QQ plot. QQ stands for quantile quantile, and I'm just going to go with standards, because what I had that there, and it produced that plot. Now maybe I should have, now I want it just to be one big picture. So if I want to get that back, I'll just say PAR MF row equals C1, 1, and try this again, and it makes just one big plot. And then I want to put a line through that. So I'm just going to say QQ line, and I need the residuals, so standards there. And then, yeah, I could just do that. Maybe I don't want the line to be black because I want some contrast here, and the dots on the plot are showing up as black. So maybe I want to have it be something like red. Maybe you don't like red. So you could have maybe something else that you want there, but let's just go with red and see what that does. It puts this red line on there. And that's good. So then the next thing we might want to do is we might want to get some influence measures. So aside from the leverage, right? Influence is a little different. It can involve the leverage, but let's go ahead and look at two things we might want here. So we might want Cook's distance. So let's just say we want, I'll call it CD for Cook's distance. And how we could get that, we could say Cook's distance. Oops, okay, oops. So let's just type this in. We want that for, again, our model. So we could just run that and it gives us these values for Cook's distance. Or we maybe want DFITS. And how would we do that? So for DFITS, it's a little bit more involved, but we could type in ls.diag. So you see that there. And then again, the model. And now we type in DFITS. So that hopefully seems like it makes some sense. And we can type that in. And then we could look at those things. So for example, I just want to see the first few values of the CD. So I just, for the Cook's distance, so I could just say CD for Cook's distance. And this is going to show me the first few values. I don't want to print out all 100 of them, but I could start investigating or looking at them. So if I come back here to the plots from the regression, go back a little bit, I see that there isn't a Cook's distance that is especially large, looking at this plot, the bottom right. But I can see that observation 58 looks like it's maybe the largest for Cook's distance, at least in terms of absolute value. Maybe it appears that way. So maybe I want to make a subset. I want to, let's say, just remove one observation. So let's just do a couple of things here. Let's just say I've got the max of CD, and I don't know what that'll be, but let's just give that a try. It says 0.006 or 0.066. Let's just check out removing an observation. So let's just say CD2, and I'm going to say this is CD, and I'm going to take and remove observation 58, because I look over here and it appears that that is the, it's hard to see precisely. Maybe it's one of these up here, but let's just, maybe it's observation 71. But let's just remove that observation 58 and see what this does. Oh, incorrect number of dimensions. So let's just try it. This, because it only has one variable. And now let's just see if that was the max. Harder to tell over there. So max CD2, and see if it's still the point. Yeah, 0.066. It's not, right? So we got rid of that observation 58. And it says the new maximum now is 0.0548. Okay, so I did that just eyeballing this over here on the right. I could see that this observation 58 had what looks like to be a fairly large Cook's distance. Now, let me take that back. When I say fairly large, I'm meaning relative to all the other observations that I see. This value of 0.066 is not a large Cook's distance. So just I was referencing it in respect to the other observations there, right? That it was the largest, and that's what it came out as being this max. But that's how you could remove an observation from a data set. You could call this subsetting, right? These brackets here are for subsetting. So hopefully this video helps just in getting started and working through some of the homework. And with that, I, again, hope that it's useful for you, and good luck with everything.